Okay. So, like Bojan mentioned, you have iPerf 3, right? And is it better if you use iPerf 1 or iPerf 3? What the hell is iPerf 2? And the protocols are not even compatible. And like we said before, I mean, iPerf is designed to measure from a backbone network from this point to this point. It creates only one port and only one single thread, one core, and that's about it. I mean, its performance is pretty great because it's very simple code, written very close to the CPU, close to the memory. So I mean, it's cool. It's cool for what it does. If you want to benchmark the network driver, the network card, the cable, it's kind of nice. But we want a tool that, I mean, it would be a go-to tool for everybody. If you just install Linux right now, or maybe even Windows, because we also have like a Windows version, you install it and you can use it straight away as iPerf. And we also have this functionality for the RMBT protocol. Actually, this tool of ours is an implementation of the RMBT protocol. And you said that we already have it. It's an European standard, and yes, we are using it. We are using it, and we like it. But for some things, you want to measure latency, right? I mean, bandwidth is not, it's only half of the picture. I want to know how fast I can put a bullet in somebody's head across the world, right? In Counter-Strike. And and yes. And for this you need the ping tool, right? Or if I want to measure my provider, is my provider fast enough? Then I need what? The speed test CLI or something, because it would be very unrealistic to expect that a home user will install our Java client for RMBT to find some measurement server in an obscure place in the world. That, yes, that would be pretty unrealistic, right? And there is a lot of fragmentation. So that's why we made this new tool. And we want to achieve extra high performance, because we noticed with RMBT, for example, on my computer, I can only achieve like 100 gigabytes on this laptop. So you put your 100 gigabytes card in this laptop, and you're limited to 100 gigabytes. But what if you want to go a little bit faster? And it turns out that because iPerf is not designed for modern computers where you have like multiple cores, really fast memory, it will not be able to achieve. I mean, I'm partially joking, because this computer is like a very special case. Even if it's like a low power laptop, it can achieve like unbelievable performance. But we have like a huge server which uses a lot of power and is limited to 40 gigabytes. So with iPerf, exactly because it can only use one core of our 96 cores, however many we have, right? We want it to be unified. So what it means to be unified, I want the same tool to use it for everything, and I want it to be pretty. What does it mean to be pretty for a CLI tool? Does anybody have an idea? I mean, in my opinion, Alexei implemented like a tool that does graphs, like these ones, and we think these are very pretty. So yeah, we still have to fix a little bit of prettiness, because you see these gaps here and stuff like that. But it's only beta. Other than that, we believe it's quite pretty.
But spoken of which, like, because our designer is on honeymoon right now, right? So we cannot really make it so as pretty.
And yeah, the designer was not involved in the CLI part of the creation of the tool. And we want to be maximum easy to use. So maximum easy to use, it means it has some very easy of life features. So for example, our tool is called Nettest, very easy to remember. And you just do nettest enter, and it automatically finds a server, and it works exactly like speedtest CLI, and it does the measurement against the closest server that it automatically finds.
Speedtest CLI, that means we didn't do any tests. This is why I'm asking. Besides, you could basically connect with the speedtest CLI with any speed test server that is available publicly, or this is you don't have any.
Honestly, I don't use it because I don't like speed test at all. So
Yes, you can. You can.
yeah, I have like
You can try.
the problem that I have with speed test is that if I want to measure my internet, it usually goes by default to the to the server in my network. So I'm measuring just the network of my provider. It doesn't tell me anything about how fast I can watch Netflix or go to Amazon or whatever. So it's designed from the get-go to not tell me to anything. Basically, it tells me that there isn't any broken connection.
Yeah, but basically, I think you can also manually choose the server.
Absolutely, yes. You can absolutely manually choose a server, but that's not very user friendly, right? I would have to search for a server, and it will. We actually plan to implement a feature to list the servers from our repository, and then you'd be able to much easier choose because we want to make it maximum easy to use. We also want to make you register your own server, like with only a command line parameter. You run your own server and you can automatically register to our backend, and then everybody else would be able to use it. It will be unverified by default, so it would appear in an unverified list, but still, I mean, it would be very easy to run your own server. And for this, you need to have some server-side considerations, and you might think, what are the server-side considerations? So basically, how fast is your network? If you're measuring like less than 10 gigabytes a second networks, there are none considerations at all. I mean, it runs really easy on pretty much any bare-bone hardware. Any old box that you might have at home, it would be able to easily do like 10 gigabytes with no CPU limit, with no memory limit. The only thing is that you need to have a 10 gigabytes network card in it, and that's it. But if you have like more than that, then there are some parameters that you might need to tune. For example, if you want to go like over 50 gigabytes or even to 100 gigabytes, you might need to configure the number of workers that you want the server to run, because we already pick the default number, which is equal to the number of cores that you have, but sometimes on the AMD CPUs, that's not the optimal number, so you need to tweak it a little bit. But that's only when you want to go over like 50 or 100 gigabytes. Will it be a public server? And for this, you need to open the ports, generate some SSL certificates, and yeah, that's pretty much it. The reason that you want to do the SSL certificates is that we are doing TCP measurements when you want to go like on the backbone and measure maximum speed, but we can also do SSL certificates when you want to see end-to-end if your hardware is capable of doing encryption, like most of the web is so far, or you can also do WebSocket, right? Which is very, very helpful for applications, because if you want to achieve minimum latency and maximum speed multiple threads, you would want to go through a socket for all this. So to do WebSockets are not possible in the browser anymore without SSL. So in order to do this, you need to provide a certificate, register it to our server or not, and that's it. If it's an embedded device, because our performance is like pretty awesome, so if it's an embedded device, it might run pretty great, but you have to do some benchmarks before to see where your limit is, because it might not be like everything. But for example, I have like some embedded devices at home which can do 12 gigabytes or something like that, but their NICs are not 12 gigabytes. I'm simulating on the local host interface, but they can do like 12 gigabytes easily. So just keep that in mind. And why do you think this is relevant? We think this is relevant because we envision that you would automatically run our server in your network for checking all the time. Is my TV connecting okay with my other devices? Is my computer connecting okay? So so you can even run it on a network, on a router, like a package, and it will not interfere with the rest of the network because it uses very little resources, especially if you're measuring up to 2.5 gigabytes or something. So we did some benchmarks because Bojan mentioned earlier that he compared iPerf. You recognize this. So this is on my laptop when it's plugged in, not right now. So with iPerf we can do like 100 gigabytes when sending and when receiving. I mean, the main limitation is that we are moving a lot of data around. The tool is moving a lot of data around, and you would say it reaches the limit of the memory. How much data can the memory move and how much data can the CPU provide? But Oleksiy managed to do this with our tool. And this for receiving. So it's not like 3%. It is like 20%. Yeah, so now maybe we can try to do a live demo because it's exciting. I will run it on my home network because
Okay.
I
Just a question. How do you manage? Or let's say you are using TCP.
yes.
So we, from our experience from the RTM Nettest, the problem that we have at high speeds or bandwidth is the single CPU performance.
Yes, it's multiple workers.
So you are putting one TCP stream on one CPU, another one.
I think the implementation details Oleksiy will be able to address.
Several workers, each worker one core. One core, yeah. So you're dealing one TCP thread per CPU. Per core. The core.
Yeah, but okay. Obviously, we can manage more. Yeah, but like the optimal one for high-speed measurements will be if you run one measurement.
Yeah, this is the.
But for sure, when we run it more. I tested with different options, but what is at least one thread per one core, but maybe 2 or 3 because still they can wait. They can wait for response. That's why even more. So default one is 50 workers. For 16 cores. It works perfect. 50 workers.
50 workers for
Yeah.
16 cores.
Yes, because they have to wait response time to time. That's why operation system manages it very well.
Basically, one full active thread
Per one
core.
Yeah, this is
Because the thread can also become inactive, so
Yes.
the other can
The other
also
can, yes,
yeah.
absolutely.
But basically, simultaneously one TCP thread.
Yes, absolutely.
So, well, we're going to go for maximum difficulty in presentation, in live presentation. We are going to download the software from GitHub, install it, run it, and see if it works or not. So,
What can go wrong?
yeah, exactly. Not here, so. Secure. Nettest. So you need to go here if you want to do this at home. And then we go to releases. It's the alpha version, so it's extra exciting. Okay. So I will start a TMOX session, which I will try to split like this and like this. Here we're gonna have the CPU stats, and here I want to show you what is the CPU that I have on this machine. So no funny business. It's like this Intel Atom CPU uses, I don't know, maybe 6 watts, and is from 6 years ago or something like that. so this is how we run a server. And now we run the client. And it's exactly like iPerf, see?
How do you do ping?
Oleksiy,
It's the same as everything.
Via TCP, basically.
Yeah.
Okay.
and you can look there at the CPU usage. Basically, right now it only started like 2 threads. Maybe we could try with more, maybe with 4 workers. Maybe it could achieve even better. And I could probably even show you how easy it is to do this. When we run this software for the first time, it automatically creates a configuration file with some defaults, and then you can just adjust those defaults. But I will let it finish. So no error, it finished. Okay, let's do this, nettest.conf. It says it's starting 30 workers. So maybe we need to see if that is really happening or not.
I think maybe you need to run a client with more threads. So
Okay.
run -c, nettest -c, and -t, and run maybe 5 threads or 10
4.
threads.
Let's see. Maybe yes, maybe no. But in any case, I mean, this is our demo, and it didn't crash. I mean, the window is still holding strong.
Yeah.
I also prepare like this pre-recorded demo in case it didn't work, but it worked. So yeah, let's go.
Only 2 cores will run our.
Yeah, but in our testing, of course, in our testing on my laptop, for example, I can also show you, I can also run it on my laptop, but on my laptop, if I show you the terminal, you see the fonts are going to be really small. So I don't have a good way to increase the font size in my terminal because it's like the most minimal terminal ever. So that's why I ran it on the web.
So this was not with encryption or without?
This was without encryption.
Can you run it with encryption? I would like to see the CPU load.
Yes, I could, but I don't have the SSL certificates because I just downloaded it and I didn't prepare anything in advance. I didn't prepare, so.
CPU load with the encryption.
Much higher.
Yes, yes.
Much higher.
Yes, yes.
Okay, much higher is enough for me.
Yes, I have like on my M1 Max, I reached 100 gigabits locally with TCP, and with TLS, with current libraries, it's like around 65 or 70. It's like 70% from
Okay.
TCP.
Yeah.
Okay.
This is what.
Yeah, it's much. Yeah. Okay. And also both directions? Or
But I will explain. I will explain.
okay. Nice.
Yeah.
Because
we have seen differences in.
we didn't deliver it
Yes,
slot.
yes.
I will say about it. So
Okay.
we improved a bit.
Yeah, so for example, when I did that benchmark that you saw 100 gigabytes download with Hyperf or whatever with our tool, basically I took my laptop in the garage and I was shooting compressed air in the fan because it throttles, it heats up really fast and it throttles, I mean, during the direction of, during our test. So with this little trick, it managed to go both directions without throttling. Yes, and we have this as an open source project. You can contribute, and by contributing, you don't necessarily need to send pull requests. You can send pull requests. We would be happy with that. But we will also be happy if you liked and subscribed. Yeah, thank you.